Hello students, welcome to my session. Myself S. Vanaja, lecturer in physics from Government Polytechnic Nirmal. Today I am going to explain the echo and reverberation concept. Echo. What is meant by echo? So in our daily life, we observe so many sounds and so many echoes. Echo nothing but it is a sound which will be a repetition of sound due to a reflection at the obstacle. It is a repetition of sound due to the reflection at the obstacle. The obstacle will be either wall or building, mountain or trees, anything. The obstacles will be so many obstacles are there in our daily life. We observe so many obstacles in our daily life. So the sound waves are moving towards that obstacle and get back to the same person. So there is a reflection at the obstacle. So you can see this figure in this in the slide. So the person making sound by clapping. So due to claps, the sound is produced and the sound waves are moving towards the wall, and here wall as acts like an obstacle, and the sound waves are incident on the wall and reflected back to the same person. So the person hears the direct sound as well as the sound due to reflection at the obstacle. So the repetition of sound due to the reflection at the obstacle is called as echo. So due to only one reflection, we can hear the same sound after some time. So here the examples for echo. Examples for echo. So echoes are heard due to reflection of sound, as we know that. And here the examples are the echoes due to nearby reflecting surfaces or buildings or the surface of the wall or surface of the mountain or cliff. So here the person is shouting, you can see the figure, the person is shouting and the sound is produced. So here the original sound is moving towards the wall and the reflected sound is reached the same person. Here the wall acts like a reflecting surface. This reflecting surfaces will be either wall, mountain, building or anything. So these are some examples for echoes. Now what is the time? What is the distance between the obstacle and the person? The relation between time of echo and the distance of obstacle. And what is the minimum distance between the source and the observer to hear an echo will be discussed here. So for that I am observing one reflecting surface. I am considering one reflecting surface PQ. So PQ is the reflecting surface, and A and C are the positions of source and observer. So A is the position of the source, C is the position of the observer, and PQ is an obstacle or reflecting surface. So here the source is at A point and the source of sound is producing some sound waves, and these sound waves are reaching or are moving towards the obstacle, that is PQ. So from A the sound wave is moving towards the wall or the reflecting surface. So what happens? The sound waves are incident at B point on the reflecting surface. At B point, B is the incident point, the position of the sound waves on the reflecting surface. They are incident on the reflecting surface at point B. and they are reflecting back in the, or it is they are the sound waves are reaching the observer. So if you observe the paths of the sound wave before and after reflection, so here AB is the path of incident sound. The incident sound path is AB, whereas BC is the path of reflected sound wave. So the sound wave is reaching the observer. The observer is at the C point. The position of the observer is at C. So the reflected sound wave reached the person or the observer in BC direction. So AB is the path of incident sound and BC is the path of reflected sound wave. So here the observer can hear the direct sound also. The source is producing the sound waves from A point. So the observer at C position can hear the direct sound in AC direction, and the person can hear the echo which is coming in ABC path, which is reaching that person in ABC path. So the direct sound path is AC and the echo path is ABC. The echo path is ABC. Am I clear? So direct sound is along AC and echo is along ABC. Now I am concentrating on the time required to hear an echo. What is the time required to hear an echo? So to find the time, we know that velocity is equal to distance by time. So the time is equal to distance by velocity. Which distance? The distance travelled by the sound. The distance travelled by the sound by the velocity of sound. Here the sound is moving in AB path and in AC path. So the distance travelled by the sound by the velocity of sound gives the time required to hear an echo. Now observe the distance travelled by the sound. What is the distance travelled by the sound here? It is AB plus BC. What is the total path? It is AB plus BC. So I am just substituting the distance travelled by the sound here as AB plus BC by the velocity of sound is V. Now AB. Let us consider the AB distance is D. So the same way BC is also it is D. So why? Because AC are the distance is same from B point. The position of the source and the observer is same. I am considering like that. So AB plus BC is nothing but D plus D by the velocity is V. So what will we get? Time to hear an echo T is equal to 2D by V. Here to find the minimum distance, I am concentrating on to find the minimum distance to hear an echo. Here the minimum distance between the source and the observer to hear an echo, that is D is equal to V into T by 2. As we know that the velocity of sound is 330 meter per second and the persistence of hearing is 0.1 seconds. So here 0.1 second is the persistence of hearing, means to hear two sound waves, here the person or the observer can hear two sound waves, the direct sound in AC along AC path and the echo in ABC path. So here the two sound waves, differently, the minimum time difference between the two sound waves is equal to 0.1 second. If it is less than 0.1, we can't hear the two sound waves separately. They just overlap. Human ear can't hear the two sound waves differently if the time interval between the two sound waves is less than 0.1 second. So that's why the persistence of hearing, means the time interval between the two sound waves must be 0.1 to hear two sound waves separately. So that's why I am substituting the time interval t is equal to 0.1 seconds in the equation, whereas v is equal to 330 meter per second. So substitution is d is equal to 330 into 0.1 by 2 will get 16.5. So 16.5 is the minimum distance between the source and the observer to hear an echo. 16.5 meters. Now the methods to minimize echoes. The methods to minimize echoes. What are the methods and how to minimize these echo concept in our houses or in auditorium or seminar halls? Because due to reflection of that reflection at the surfaces or at floors or at ceiling, the sound wave is reflecting back and we are hearing the same sound repeatedly due to concept of echoes. So if we hear the same sound repeatedly, what happens there? It causes some disturbance in some auditoriums or in seminar halls where we are able to hear the same sound repeatedly. So we have to minimize these echoes in auditorium or in seminar halls or in theaters. So how to minimize these echoes? Why? Because these are causing some disturbance. So let us discuss these minimizing methods of echoes. The first one is by constructing rough surfaces. By constructing rough surfaces. So if the surface is smooth, then more intensity sound wave will be reflected back. Most of the sound wave will be reflected back and reach the observer. If the surface is rough, then what happens? Most of the sound wave will be absorbed at the wall and remaining so very less amount of sound wave will be reflected back. So that's why we have to maintain the rough surfaces. By constructing rough surfaces, we can reduce the echoes. And the second one is having polished and low ceilings. Having polished. During the polishing, we have to use the sound absorbing materials. If we use sound absorbing materials, most of the intensity of the sound energy will be absorbed at the surfaces. So during the coating, so we have to use the sound absorbing materials during the polishing of the surfaces. And we are maintaining the low ceilings. So why we are using the low ceiling means, so we know that the minimum distance to hear an echo is 16.5 meters. Suppose if the ceiling is too large, then there is a possibility for to hear an echo. So that's why we are using the low ceilings to reduce the echo concept in the seminar halls. So having polished and low ceiling is the method, one of the methods of minimizing methods of echoes. And the third one is providing the large number of doors and windows. So if we provide large number of doors and windows, so much of intensity of sound wave will be go outside. And so we are providing the large number of windows and doors to minimize the echoes. And the fourth one is providing good sound absorbing materials. So here in the room we are using some curtains or carpets. So these are the very good sound absorbing materials. So by maintaining the curtains or carpets or any sound absorbing materials or some furniture in the room will be acts like an absorbing surface, and so much of sound energy will be absorbed by the materials, and very less amount of energy will be remains. So in this way we are minimize the echoes in our rooms or houses or seminar halls or anything. So what are the concepts? What are the methods? By constructing rough surfaces and having polished and low ceilings, providing large number of doors and windows, and providing very good absorbing materials. So here I used some slides here, sound absorbing walls here and soundproof ceiling, you can see the slide, and these are carpets are very good absorbing materials. So like these are the methods of minimizing echoes. Next one, the applications of echoes. The applications where we use these echoes. There are so many applications for echo concept, and I am just explain some of the applications. So here this concept is very much used in sonar. So sonar means sound navigation and ranging. The position and distance of the submarines can be determined. The actual position or the distance from the surface, where is the position of the submarines, and in which direction it is moving, and what is the distance from the ground. So this can be calculated by using the echo concept. For this we use ultrasonic sound waves, and these are sent into the sea directly, and at the submarines the sound wave will be reflected back, and by analyzing this reflected back sound wave and the distance between the ground and the submarine will be calculated from the same formula, d is equal to vt by 2. Just by observing the echo, the time required to hear an echo will be calculated, and we know the velocity of the ultrasonic wave which will be sent into the sea. So by knowing the velocity and the time to hear an echo, we can directly find the distance of the submarine from the ground, that is v d is equal to vt by 2. That is a concept that in that method we can directly calculate the distance of the submarine from the ground, and in which direction it is moving, and what is the actual position of the submarine, or we can calculate, or we can estimate the any moving objects in the sea. We can observe any moving objects which are moving under the sea, and the position and distance of enemy aircraft can be determined. The height of the aeroplane or the depth of the oceans can be determined. In this echo concept, we can calculate the height of the aeroplane also. So for that concept also, we are sending the ultrasonic sound wave in a upward direction, and we observe the echo, time of echo, and using the Vt/2 formula we can find the height of the aeroplane as well as the depth of the sea. And echo technique is used to find the tumors and the kidney stones or status of fetus in the mother's womb, and also in heart scanning. So echo concept is used to find the tumors in human body. Where is the tumor, and what is the kidneys, the size of the stone, and the status of the fetus in the mother's womb, and what is the functioning of heart, and what is the functioning of other parts of the fetus can be estimated by echo concept. So there are so many applications in the medical field for echo concept. And here the echoes are used by the bats. So since bats cannot see in the night time, so there uses this echo concept, and the echolation to locate their ways. They produce, and they can use ultrasonic waves, and by the reflection of the obstacle they move in the night time. The bats can move in the night time by using the echoes and ultrasonic waves. The velocity of the sound can be determined. The velocity of sound also can be determined. So here in the slide you can see, so here the scanning in a echo scanning or echocardiogram ECG, we are using the echo concept. So see the slide. Gel is placed on the chest. Transducer sends the sound waves through the chest to heart, and the sound waves bounce back to heart to transducer. And the fourth one is computer process sound waves to make visual of beating heart. So in this way the heartbeat can be analyzed, and there is a clear picturization of the heart will be, we can get the information about the complete information about the heart, so by ECG, so using the echo technique. So here the bat, so it produces ultrasonic waves, so ultrasonic waves, and here at the another insect, the echo, the sound waves are reflected back and they reached the bat. In this way the bats can easily estimate the position of another obstacles nearby the bat in the night time. So echoes are used to find the velocity of the sound wave by using the formula 2d/t. Next, the reverberation. Reverberation. What is meant by reverberation? Reverberation is nothing but the persistence of hearing in an enclosure as a result of continuous reflections of sound at the walls, even after the source of sound has been turned off. So there is a small difference between the echoes and reverberation. The echoes are due to one reflection of the sound. The reflected sound due to one reflection. Whereas in reverberation, there is a possibility for multiple reflections in an enclosure. Suppose in an enclosure, So see here the figure, the person is talking. The person is talking. So here the direct sound, the person talking and the sound waves is moving in the direction and it is reflected and reached the observer. And there are so many ways, of sound waves reaching the observer. You can see in the slide the direct sound and the sound after one reflection and the sound after two reflections, after 3, 4, 5, 6, anything, n number of reflections. There is a possibility for n number of reflections. Why? Because there are so many surfaces in an enclosure. So at every surface the sound energy is reflected back and finally reached the observer. After one reflection it is reaching, and after two reflections at the surfaces, finally the sound wave is reaching the person. Like that, there are multiple reflections. After multiple reflections, even after the source of sound is turned off, the person is can able to hear the same sound repeatedly. So this persistence of hearing in an enclosure is called as reverberation. The persistence of hearing in an enclosure as a result of continuous reflections at the walls of the enclosure, and even after the source of sound has been turned off. And here, see here, in another slide, the prolongation of the sound in an hall even though the source of sound is cut off is called reverberation. There is one more definition. I am mentioning one more definition for reverberation. So there is a prolongation of sound. Means the sound is repeatedly hearing by the same observer. There is a prolongation of sound in the hall even though the source of sound is cut off. That is called reverberation. And the sound produced in the hall undergoes multiple reflections from the wall, floor, ceiling before it becomes inaudible. Up to inaudible stage. Up to reaching the inaudible stage, the sound waves are repeatedly undergoes the multiple reflections at the walls, floor, ceiling. So many reflection surfaces are there in the hall. So the sound wave undergoes multiple reflections and reaching the observer. So the person can hear, suppose if sound waves is initial sound intensity is suppose 50 decibels. After one reflection it becomes some 45 decibels. After two reflections it is 30. After 5 reflections it becomes 10 decibel. Suppose the inaudible intensity is suppose 2 decibels. Up to reaching the 2 decibels, the persons can able to hear the same sound due to multiple reflections at the walls of an enclosure. This is called reverberation. Now, threshold audibility and time of reverberation. What is meant by threshold audibility? Threshold audibility nothing but it is a minimum intensity of sound which is inaudible. It is not equal to 0. The sound density is not equal to 0, but it is a minimum intensity of sound which is inaudible for the person is called threshold audibility. Now the time of reverberation. The time required by the sound intensity to decrease the threshold audibility. Suppose threshold audibility is 2 decibels. Let us suppose it is 2 decibels. and the initial intensity is 100 decibels. The time required by the sound energy to decrease threshold audibility from an initial intensity of 10 power 6 times of this after the source of sound is turned off is known as reverberation time. Here the initial intensity will be considered as 10 power 6 times of threshold audibility. From that intensity, the intensity is gradually decreasing due to multiple reflections and reaching finally threshold audibility. From where it is 10 power 6 times of threshold audibility to reach the threshold audibility. What is the time required? What is the time interval between these two positions? Will be considered as time of reverberation. Time required by the sound intensity to decrease the threshold audibility from an initial intensity of 10 power 6 times of this, even after the source of sound turned off, is called as reverberation time. And the reverberation time mainly depends on the volume of the room. If the volume of the room means is more, then there will be possibility for more number of reflections. Then the time of reverberation will be more. Am I clear? So here the volume of the room depends on the reverberation depends on the volume of the room, and also nature of reflecting material. The nature of reflecting material. Then the ceiling, area of reflecting surfaces, the frequency and intensity of the sound which is produced, and the reverberation should not be too large and too small. The reverberation mainly depends on volume of the room, area of the reflecting surface, nature of the reflecting surface, and the ceiling, the frequency and intensity of the sound. And this reverberation should not be too small or too large in the enclosure. It should be optimum. Optimum reverberation should be maintained in the enclosure. So what is the value of optimum reverberation? It is 0.5 to 1 second. Reverberation time lies between 0.5 to 1 second. So here the reverberation, I already mentioned that reverberation time will be not too large or too small. What happens when it is too large? Suppose when the reverberation time is too high, the reverberation remains in the hall at very large time, more time. Then sound prolongation is more. So the sound produced by the speaker will persist for a long period of time. Means it causes some disturbance. And similarly, if the reverberation time is low, it is very low, then sound dies quickly and becomes inaudible in very short amount of time. Before reaching the observer, it dies. The total sound energy will be vanishes. So if it is too small, then it is inaudible for the person. If it is too large, then what happens? The sound waves will be overlapped. There is a confusion, there is a disturbance. Means there is no clarity in the sound wave. Suppose if the reverberation is too large, there is no clarity. We lost some clarity. If it is too small, we lost, means it is inaudible. So that's why we can conclude that the reverberation time is not too small and not too large. It is in between 0.1 to 1 second, 0.5 seconds to 1 second. And optimum reverberation should be maintained in the hall. And here, by decreasing the total absorption coefficient of the hall and by placing sound reflection boards inside the hall, we can reduce the reverberation in the hall by decreasing the total absorption coefficients of the wall and placing sound reflection or reflection boards inside the hall. So these are the methods for reverberation. The Sebine's formula. Sebine's formula. So here the Professor Sabine introduced an equation for reverberation time. Sabine defined that reverberation time as the time taken by the sound intensity to fall 1 million of its original intensity after the source stopped. So it is 10 power 6 times of threshold audibility to threshold audibility is the time of reverberation. And this time of reverberation is directly proportional to volume of the hall. Volume of the hall. And it is inversely proportional to absorption. Total absorption in the hall. It is directly proportional to volume of the hall and it is inversely proportional to absorption. So T is equal to K into V by A. It is K into V by A, where K is the proportionality constant and this K value is equal to 0.16. So T is equal to 0.16 V by A. So T is equal to 0.16 V by A is the Sebine's formula. So V is the volume of the hall, A is the absorption. And how to find this absorption is, see, T is equal to 0.16 V by sigma alpha NSN, where alpha 1, alpha 2, alpha 3 are the absorption coefficients. Here S1, S2, S3, S4, these are the areas of reflecting surfaces. Areas of reflecting surfaces. So totally A is equal to alpha 1 S1 plus alpha 2 S2 plus alpha 3 S3 and so on. Alpha n Sn is the total absorption and V is the volume of the hall, T is the time of reverberation. So finally T is equal to 0.16 V by A. Now let us discuss some problems based on the echoes. So a man hears an echo of his voice from a distant object after 2 seconds. If the velocity of sound is 338 meter per second, what is the distance of object from the man? So D will be calculated. D, the distance of the object from the man. So where the velocity of the sound is 338 meter per second, time to hear an echo is 2 seconds. So we know that D is equal to Vt by 2. So that is 338 into 2 by 2, which is equal to 338 meters is the distance between the object and the man. And here a boy is standing between the two parallel walls, fires a gun. He hears the first echo after 3 seconds, after 3.4 seconds and the next after 6 seconds. Find the distance between the two walls and the velocity of sound is 340 meter per second. So a person is standing between the two walls and there are two reflecting surfaces or two obstacles and he hears, he just fires a gun, so that sound is moving in the two directions, during the first wall and during the second wall. Okay, in the direction of the first wall he hears echo after 3.4 seconds, and due to the second wall he hears the second echo after 6 seconds. So the time for first echo is 3.4 seconds. So d1 is equal to the distance of the first wall from the boy. d1 will be vt1 by 2. So 340 into 3.4 by 2. So that is 578 meters is the distance from the boy to the first wall. Now the distance of the boy from the second wall, that is d2 is equal to vt2 by 2. So it is 340 into 6 by 2. So 1020 meters. So what is the distance between the two walls? So the distance between the two walls is nothing but the distance from the boy to the first wall and the distance between the boy and the second wall. So it is sum of d1 and d2. So 578 plus 1020, it is 1598 is the distance between the two walls. Now a boy hears an echo of his own voice from a distant hill after 2 seconds. If the velocity of sound is 340 meter per second, find the distance of hill. So t is equal to 2 seconds. Velocity is 340 meter per second. So distance d is equal to vt by 2. So 340 into 2 by 2. So it is 340 meters is the distance from the boy and the obstacle, that is hill. And finally there is a problem based on the reverberation. The volume of the hall cinema theatre is 2000 meter cube, and the seating capacity of the theatre is 1000%, and the coefficient of absorption of each person, coefficient of absorption nothing but it is a 4.5, and find the time of reverberation. So volume of the cinema theatre V is equal to 2000 meter cube. Seating capacity means 1000%. So total absorption means sigma AS. Total absorption means sigma AS. So here A is given, that absorption coefficient, that is 4.5, and S is the reflecting surfaces, means here 1000 persons are there in the theatre. Okay, so 1000 capacity, the seating capacity is 1000, means the 1000 chairs will be present in the hall, and 1000 chairs seats are acts like an 1000 reflecting surfaces. So 1000 into 4.5, that is 4500 is the total absorption in the hall. So time of reverberation T is equal to 0.165 V by sigma AS. So T is equal to 0.165 into 2000 by 4500 is equal to 330 by 4500, that is equal to 0.073 seconds at the time of reverberation. So this is the, here I am calculated the absorption from the equation sigma AS and substituted in the equation. And how to find the absorption? It is absorption coefficient into S. S means seating capacity, means 1000. 4.5 into 1000, that is 4500 is the total absorption. So in the fourth problems, this problem will be somewhat difficult compared to other one. Means here the boy is standing between the two parallel walls means and fires a gun. The person is standing in between the two walls. The sound produced by the boy is moving in two directions. One sound wave is moving towards the first wall and another sound wave is moving towards the second wall. And due to the reflection at both walls, the reflection sound will be finally reached the person means he hears two echoes. Due to the first wall he hear and the echo after 3.4 seconds and the person hear the second echo due to the second wall after 6 seconds. So what will be the difference means the distance between the two walls will be calculated. So by using the formula, so here d is equal to Vt by 2. First of all we are calculating d1, that is Vt1 by 2, and then we calculate d2 is equal to Vt2 by 2. What are d1 and d2 here? d1 is nothing but the distance between the person and the first wall. d2 is the distance between the person and the second wall. If we add these two, d1 and d2, we get the total distance between the two walls. So d1 is equal to Vt1 by 2, 340 into 3.4 by 2. So we got 578 meters, and d2 is equal to Vt2 by 2, 340 into 6 by 2, it is 1020. So distance between the two walls d is equal to d1 plus d2, that is 578 plus 1020, which is equal to 1598 meters. So this is the problems based on echoes and the reverberation. So thank you one and all.